All right, guys, before we get started, are there any questions over the homework? Any questions over the homework assignments? What we're talking about today is complex conjugates, or the first thing we're talking about is complex conjugates. Now, the complex conjugate theorem states if a polynomial with real coefficients, and a plus bi is an imaginary zero, so if a plus bi is a solution, it means that a minus bi has to be a solution. So a plus bi is a complex number, and its complex conjugate is a minus bi. So if we're given a plus bi, its complex conjugate is a minus bi. If we're given a minus bi, its complex conjugate is a plus bi. And this theorem states if we get a complex number as a solution, we have to have both. So if they tell us 1 minus I is a solution, it means that its conjugate 1 plus I has to be a solution. If we have one, we have to have the other. They always come in pairs. 7 minus I. What would the complex conjugate of 7 minus I be? That's the complex conjugate. Now, before we move on to the next one, let's multiply these two together. You don't have a whole lot of space, so you can watch this here. There is something interesting that does happen. If we multiply these together, the first thing we're going to do is distribute the 7. 7 times 7 is 49. 7 times I is going to be plus 7i. Negative I times 7 is going to be negative 7i. And negative I times I is going to be negative I squared. Now, 49 does not have any like terms. Our middle term, 7i minus 7i would be 0. So the middle terms cancel. Now, we can't leave I squared, I to a power. Well, we know that I squared is negative 1. So we're saying we have 49 minus negative 1, which is the same as saying 49 plus 1, which would be 50. So the interesting thing with this here is when we multiply the two conjugates together, we get a number without I.
So 50 is the complex conjugate?
Well, the complex conjugate for 7 minus I is 7 plus I. Their product is 50. And it works out whenever we multiply two complex conjugates together, we're going to get a single number. The I terms will cancel out. So negative 5 minus 5i's complex conjugate would be what?
It would be plus 5 plus negative 5 plus 5i. Oh, yeah.
Because a plus bi and a minus bi. So negative 5 minus 5i, complex conjugate would be negative 5 plus 5i. Now we can multiply those together. Negative 5 plus 5i times negative 5 minus 5i. Somehow I hit enter. Negative 5 minus 5i would indeed be 50. Now it just works out incidentally that both of these are 50. It's not always going to be 50. But their product will always give us a number. Questions on 1 and 2? So let's look at number 3. Negative 2 plus 4i's. Complex conjugate would be what? Negative 2 minus 4i. Negative 2 plus 4i and times negative 2 minus 4i is 20. All right, 3 minus 6i's complex conjugate would be 3 plus 6i. Didn't ask us to find the product, but if we did, we can multiply these two together and get 45. Questions? So number 3 would be 20 if we found its product. Not on these, but the homework, yes. It's going to ask for both. Because product is just saying we're multiplying -2 plus 4i and -2 minus 4i. Multiply them together.
How are the places you'll get?
Questions on 3 or 4? Guys, answer yourself.
Answer yourself, Ryan.
Number 5, what would the complex conjugate be?
10 plus 2i.
Number 6,
Minus 4 plus 8i.
-4 plus 8i. 7, -4 plus 3i.
That's it.
And lastly, 8 plus 3i.
We're not putting products.
Not on these, but the homework, there are the first 5 do ask for the complex conjugate in their product. But if we're doing product, all we're doing is multiplying the 2 together.
That's close.
Questions on this here? Questions on anything we've done so far? What would the complex conjugate of -17i be? So if they gave us -17i, the complex conjugate would be 17i. Now, what's the complex conjugate to 9?
Now if it was
Because really,
Oh, it didn't mean negative. I don't know.
because with -17i, we can say 0 plus 17i and 0 minus 17i, or 17i and -17i. So for 9, well, it's 9 is the same as saying 9 plus 0i, and its complex conjugate would be 9 minus 0i. So really, the complex conjugate of 9 is 9. Because we're only changing the sign in front of the I term, not the real term. Now, the other part of the lesson, we are going to divide these complex terms and write it in standard form. Now, I'm going to rewrite it. You don't have to. I'm going to rewrite it so it's just a little bit easier to see. Now, the issue with this here is we cannot have I in the bottom of a fraction. Now, to simplify that, we're going to use the complex conjugates. And specifically, the complex conjugate of the denominator. Because as we've seen already, if I multiply complex conjugates together, the I terms simplify out and I'm left with a single number, which will get I out of the bottom of the fraction like we want. So the denominator is 1 minus 2i. So we're going to multiply by its conjugate 1 plus 2i. So on bottom, we're going to distribute out. 1 times 1 is going to give us 1. 1 times 2i is going to give us plus 2i. Negative 2i times 1 is going to give us negative 2i. And negative 2i times 2i is going to be negative 4i squared. Now at this point here, we're going to do some simplifying because our 1 does not have like terms, but our positive 2i minus 2i is 0. Those are gone. And we can't leave I squared, but we do know that I squared is negative 1. Now, negative 1 times negative 4 is just positive 4. 1 plus 4 gives us 5. Now, we can't just multiply the bottom of the fraction, we also have to multiply the top. Because we're going to multiply, because we are multiplying by 1 plus 2i over 1 plus 2i. Now, the reason we're multiplying the top and bottom by 1 plus 2i is because, well, 1 plus 2i divided by 1 plus 2i is 1. Anything divided by itself is 1. So really, all we're doing is multiplying this fraction by a fancy version of 1. Now we multiply the numerator, the top. We're going to have 4 times 1, which is 4. 4 times 2i is going to be plus 8i. 3i times 1 is going to be plus 3i. And 3i times 2i is going to be plus 6i squared. At this point here, we do need to combine like terms, simplify where we can. So the 8i and 3i will combine to give us 11i. I squared is negative 1. So 6 times negative 1 will give us negative 6. So we do have like terms with 4 and negative 6. 4 minus 6 is negative 2. Now we can break this up in its 2 main parts. So like I said, we have negative 2 fifths plus 11 fifths I. Ran out of room. Questions on this here? So since he ran out of room for B, let's look at C. So, looking at this here, the bottom of the fraction is 4i. So its complex conjugate would be what? Negative 4i. So we're going to multiply the top and bottom of this fraction by negative 4i. Now the denominator is kind of nice. It's 4i times negative 4i. 4 times negative 4 would be negative 16. I times I is I squared. So the denominator is just negative 16i squared. On top, we'll have to multiply through. So we'll have 2 times negative 4i, which would be negative 8i. 5i times negative 4i is going to be negative 20i squared. On top and bottom, we don't have any like terms, but we can't leave I squared. We can't leave I to a power. So we're going to switch it to negative 1. Now on bottom, we have 16 times negative 1, which is going to be positive 16. Now our 20 times negative 1 is going to be positive 20. Now I'm going to move it to the front. Because we wanted a plus bi, we want the real number in front, our imaginary term second, giving us 20 minus 8i over 16. Now, if it wasn't in standard form a plus bi form, we would split those two numbers apart into two separate fractions with the same denominator. So we'd have 20 sixteenths minus 8 sixteenths I. Now, we could say this is the final answer as long as neither one of those two fractions is reducible. We can't simplify it. Well, 8 sixteenths is 1/2. 20 sixteenths does reduce to 5/4. So we could say that this fraction is indeed 5, or this simplifies to 5/4 minus 1/2 I. Questions on any of this here? We feel good with this so far. We kind of understand what we're doing to get here, yes? 1 plus 4i over 2 minus 3i. Let's try typing it in the calculator, because I mean, up to this point, we've been able to type all of these expressions with I in so far. So the first thing we can do is alpha y equals enter to get a fraction. Now our 1 plus 4i, so we'd have 1 plus 4, second decimal point gets us I, over 2 minus 3i. Are y'all able to get that typed in? Once you get it typed in, go on and hit enter. It worked. Second decimal. Down at the very bottom. Everybody get it typed in? Alpha y equals enter. Everybody got it typed in? And y'all got this? So unfortunately, the 30 or the 84 plus CE is a little more advanced than the one that y'all have. So let's try typing it in a different way. Now a fraction is the same as just saying dividing. We're dividing the top of the fraction by the bottom. Numerator divided by the denominator. So we're going to retype it in, but we're going to need to make sure that we do put parentheses around the terms on top and the terms on the bottom. So for this here, we're going to have parentheses 1 plus 4i, close parentheses, divided by 2 minus 3i, close parentheses. So did you get a number, something that looks like this here? Okay. So we're going to go to the next step, which is we have 3 more buttons that we're going to hit, but I want to make sure everybody's here first. Yes? Math, enter, enter. Math, enter, enter.
Dude, I'm freaking out, man.
So let's look at the next one. 3 plus 5i over 10i. So if we want to type that in, we're going to go parentheses. 3 plus 5, second I, divided by parentheses. 10, second I, close parentheses. And then once we get that number, we're going to go what? Math, enter, enter. Telling us it's 1/2 minus 3/10 I. Questions on this here? What do you feel good with this now?